Good evening, friends. I am R.M. Jalke, lecturer at Automobile Department, SJP Trust Polytechnic, Narsosi. So today I am going to solve question bank of subject fluid power transmission and control system, that is a fourth sem automobile. Okay. So under this unit 3, design of hydraulic circuits. Question or 5 marks questions. Explain the hydraulics and its applications. Now hydraulics is the science of engineering, or it is the method of transmitting motion through the medium of confined liquid. Hydraulics is based on the simple fact of nature. We cannot compress a liquid. Now if you put that liquid into a sealed system and push on it one end, that pressure is transmitted through the liquid to the other end. So hydraulics, it works on the principle of Pascal's law, pressure transmitted equally in all directions by a confined liquid. It uses incompressible fluid to supply very large forces or to transmit very large forces of slower speeds and limited range of motion. The system uses hydraulic fluid pressurized by a pump and passed through the hose or pipelines and valve to the cylinders. So advantages of this hydraulics are, so it is easy to produce or generate and easy to transmit the force, then store it and regulate it. So it is easy to control the hydraulic system or hydraulic force. Second one is low weight to power ratio. If we compare this hydraulic system with other methods of transmission of power, that is mechanical, electrical, so here high or low weight to power ratio. So we are having low weight compared to the power transmitted. Then it is smooth and uniform in operation. It continuously or it produces stepless motion. Then less noise and vibration, means it is vibration free, smoothly we are transmitting. Then transmitting efficiency is more compared to the other types, that is transmitting loss is less, like in electrical etc we are having transmission loss. Now what are the applications? Applications are, it is used in industries like metal cutting, in machineries etc, then conveyor systems, then foundries and metal plants or steel plants, then used in presses, hydraulic presses, clutch brake system, steering of automobile, then in dump trucks, in earth moving equipments. It may be used in road construction or construction industries, then in case of oceanography, in aircraft industries, or in aircraft only we are using the hydraulic system. So that is about hydraulics. Now next question is, write the requirements of hydraulic fluids. Now the fluid used nowadays in hydraulic system is a petroleum product or it may be synthetic, but in earlier days they used to use the water. Now what is the requirement of this hydraulic fluid used in the system? First one, it should have a good lubricity. It has to lubricate the parts in between it is operating. Then second one, viscosity of the oil used should not change with the temperature, it should be stable. Third one is physically and chemically it should be stable, it should not change its means components when subjected to high pressure. It should not break into particles and it should not chemically react at high temperature and pressures. Good heat dissipation, whatever the heat produced, it has to transmit or dissipate, that quality it should have. Then low temperature property, at low temperature also it should operate. Anti-wear characteristics, then anti-corrosive, it should be anti-corrosive. Then long life, low cost, total water rejection, it should not miscible with water. Then it should not be heavy, it should have a low specific gravity, and it should be non-toxic for the operator and the mechanic who is repairing it. Next one is question number 3. Write the classification of hydraulic pumps. So these pumps used in hydraulic system or in fluid power system may be classified into two types. Broad classification will be positive displacement and non-positive displacement. Positive displacement means they will give fixed amount of fluid as a output per revolution, but in non-positive displacement it will vary and there may be slippage and fluid may return, and when the pressure increases, the output reduces in non-positive displacement, but in positive displacement there is no reduction. Now under the positive displacement, again we are having rotary and reciprocating. In rotary, three types: gear types pump, vane pump, screw pump. In gear type, again we are having internal gear, gerotor, rotor, it is having external gear type. Okay, then vane type, it is having, or it may be of two types: fixed displacement and variable displacement. In vane type only fixed displacement, under that unbalanced and balanced pumps. Now reciprocating pumps, in positive displacement there are two types: axial piston and radial piston. And axial pistons, again two types: inline, that is inline or axial piston pump, and bent axis type. In inline type, again variable plate, inclinable plate, and crankshaft driven pumps. So here question number 4. Draw the hydraulic system component or symbol for hydraulic system component. So that is shown here. So different components, and you have to draw only symbol. Okay, symbols of all the components shown here. Question number 5. Explain the importance of hydraulic accumulators. So accumulator is used in a hydraulic system. A hydraulic pressure accumulator is a device that stores potential energy of an incompressible fluid held under pressure by an external source. That is called as accumulator. Now what is the purpose or function of this accumulator means? So first one is compensate for leakage in a system. So oil is pumped into the accumulator, it stores some oil there under pressure, and if any leakage is there, it is compensated by the accumulator. Second one, it acts as a shock absorber. So oil is stored, it will absorb the shocks or any sudden jerk in the cylinders or actuators, etc., that is transmitted through the fluid to the accumulator and it absorbs it. Then third one, to provide oil makeup. So it will provide the excess oil required. Then fourth, to provide a source of emergency power in the event of power failure. So hydraulic system is used in certain applications. For example, in floodgate operation, there at least it has to complete one stroke, and in that event if the power fails, that time hydraulic or this accumulator will provide the power required to complete the stroke. So in emergency it provides the power. Then to maintain steady delivery pressure, so it will remove the fluctuations. Steady or constant pressure oil is supplied continuously. Then it is used to separate oil from other fluid in the system. It will separate the fluids. Question number 6. Explain the working of spring loaded accumulator with a neat sketch. So accumulator, it is nothing but a hemispherical tank. One side we are having oil from the pump is connected, and from other side we are taking it out. So oil initially it enters into the accumulator, then it will goes to the actuator. So spring loaded accumulator is shown here. So it is having a tank, then piston, and above that piston there is a spring. So this spring that will store the compressed energy oil. When the oil is compressed, it will compress the spring and stores the energy. So this type of accumulator consists of a cylinder, piston, and spring. One or more springs may be used as the oil is pumped into the accumulator. The piston compresses the spring, thus energy stored in the spring. The spring energy stored, or the energy stored in the spring, released as required by the demands of the system, or whenever there is no pump or pump is not working, that time high pressure oil is supplied to the system by the accumulator. Explain working of gas loaded accumulator with a neat sketch. So again here it is a hemispherical tank only, pump outlet, but it is using a gas to compress. Now in this type, air or gas is used. It functions on the principle of Boyle's law. So Boyle's law states that the pressure and volume are inversely proportional at constant temperature. Now gas type accumulators may be of two types, non-separator type and separator type. In non-separator type, oil is in contact with air, and whereas in separator type, some mechanical material like piston etc. is used between the oil and gas. So a non-separator type is shown here. It consists of fully enclosed cylinder, hemispherical cylinder, and a charging valve. So a portion of oil is trapped at the bottom of the cylinder. Initially air or nitrogen or any other inert gas is then charged to the cylinder. As a greater quantity of oil is pumped into the accumulator, the air or gas above the oil is compressed. The energy is stored in the compressed gas, and it is released as required by the system or demands of the system. So this type must be kept vertical position so that gas is retained always above the top. Question number 8. Explain the construction of hydraulic reservoir with neat sketch. So reservoir means it will store the oil in the hydraulic system, and from here oil is supplied to the actuators. So different components are shown here. So reservoir, so it is important part of the hydraulic system. So functions of this reservoir is to store the oil. So it is a storage tank. Then it provides cooling of oil. After doing work, oil returns to the reservoir, and if it is large enough, oil will expand and it will release its heat, that is the cooling. It allows the contaminants to settle. So contaminant means metal particles or dust particles which are mixed with the oil, that will return to the tank and they settle down in the reservoir. It allows air to separate from oil, so air will go out through the vent hole. So different parts of reservoir are tank, filter, air vent, filter plug, strainer, pressure gauge, buffles, piping, drain plug, etc. Now tank, a large tank is required to store the oil, and the oil returning should have sufficient time to cool. So capacity of oil should be more than volume of piping, valve and cylinder. So there should be excess oil in the reservoir, means it should be more than after filling pipeline, valves and actuators. Filter, so metal particles or dust particles, they are continuously produced in the system, or they may enter through the some openings, and this should be removed, and filter is used to remove this, and filters may be fitted in many positions of the system. Air vent is to hole, or it is a hole provided for breathing of air and to filter the dust particles. Filter plug or filler plug, it is used to replace the oil, means you can refill it. Strainer, the foreign particle present in fresh oil, while replacing oil is made to pass through the strainer and is made of fine wire mesh. Pressure gauge to indicate the pressure or to measure the pressure and display it. Buffle plates, a vertical plate provided between the pump inlet and return lines for preventing continuous recirculation of the same oil in the system. Now question number 9, explain the symbolic method of ports and positions. So different direction control valves we are using in a hydraulic system. So direction control valves are described by number of port connections and positions. Example, 2-way, 3-way, 4-way, etc. and 2 position, 3 position, etc. So each position of the valve is indicated by one square, and ports by the extending outside, or the lines extending outside the box. Hydraulic flow lines by a continuous thick line. Various ports positions of 2x2, 3x2, 4x2 valves are shown here. Okay, 2 square means 2 position valve. 3 squares means 3 position valve. Then in right side there is a 2x2 valve. 2 closed ports are there, means there is no oil flow, but with arrow mark line it will indicate the flow of fluid from one inlet port to the outlet port. So there are 2 positions, that is usually it is actuated position. When you actuate it, it will close, and other positions are shown here in the sketch. So different positions of the valves. 10th question, list the common faults in hydraulic system. So what may be the faults in the hydraulic system? Reduced speed of machine tool. So usual fault will be speed reduction in machines if you are using hydraulic system. Then there may be noise in the system, or there may be increase in the temperature or steep rise in the temperature. Then non-uniform or jerky movement of tables used in feed movement of the machine tools. Then slow feed rates, suddenly it will slow down the feed rate. Then excessive leakage of oil in the system. Loss of system pressure, the system pressure may reduce suddenly. Then cavitations of pumps, pump may create the cavitations. Then no or less supply from the pump may not pump the fluid, or it may reduce the supply. Then high rate of seal failure. So these are the common faults. Apart from this, other faults are also there, but 5 marks question you can write 10. Okay. 11th question, explain the usual check procedure of a oil. So a hydraulic oil used in the hydraulic system plays vital role in the performance of the hydraulic system. So while maintenance we have to check the oil. So under that usual check, see the condition of the oil, how it appears, visual appearance. Okay, depending on that appearance you can decide whether the oil is good or it has lost its properties. Then smell, you can smell it. Then water content, whether any water is present in the oil or what. Solid particles or contents, whether there is a foaming. Then acidity of the oil, viscosity of the oil, turdiness of the oil, oxidation. So these are the factors we can check in usual check procedure of oil. Now simple checks and remedies shown in table. This you can list out. First is appearance, how it appears. Then what may be the possible cause, remedies. So if the oil is clear, means it is good oil, no action is taken. Oil is hazy or opaque, so there is a heavy contamination. Some other particles may have mixed and it has become heavy. Then it needs oil change. Third one is separated water layer drain or separated water layer. So excessive water, that is the cause of the problem. Then here remedies permit to settle or drain it. Oil has to be drained. Fourth, oil darkened, it may be due to oxidation. Check the acidity, viscosity and change the oil if it is required. Fifth one is separated deposit. So cause here is dirt, worn out particles have mixed. Then you have to filter it. Remedy is to filter the oil again. Bad odor, then oxidation. Cause is oxidation, check and change oil, remedy. Then seventh, foam in oil and oil level. So air may have trapped, check the suction line. Okay, so this is only 5 marks question. You can name the sum of the problems and remedies here. Write the causes of contamination of oil. So one of the important problem in the hydraulic system is contamination, mixing of dirt or any other metal particles in hydraulic system or dust particles. So that is called as contamination of oil. So this contamination will change the property of the oil. So if it is contaminated, system may not work properly. So for this contamination, what are the causes? First one is from new system. So once the product is brought from the factory, already it has some metal particles due to the machining, etc. So new system already generated the contaminants and they will mix with the oil and cause for the contamination. Second one, oil used to fill may be contaminated while replacing or while maintenance. Oil we are replacing it with new one, that new oil may be contaminated already. Third one, wear particles continuously generated in the system. When the cylinder and pistons are actuating, these particles are generated and these particles will mix with oil and generate the contamination or contaminants. Fourth one, due to chemical breakdown of hydraulic fluid. So continuous use or for long use, after long use, the hydraulic fluid may break into or chemically break into particles and that particles or hard particles may create the contaminant. Fifth, due to cavitation in the pumps, etc. Then rust particles due to water present in the system. Rust due to water will create this or separate the particles from the component, and these particles may create the contamination. Then airborne contaminants. So some of the air may enter into the system, but that air may have already contaminated. Then while servicing, contaminants may enter if the environment is not clean. Operator is not taking care of these dust particles, metal particles. Then ninth one, through reservoir cover. So reservoir cover is having some clearances, or it will have vent, through that also contaminants will enter. Breather and oil filling cap also may have some openings, through that the contaminants may enter. So that are the causes. Now list the preventive measures of hydraulic system. Preventive measures means before the breakdown occurs, if you take some of the steps so that we can take or avoid the breakdown of the hydraulic system. First one is keep contaminants out of hydraulic system. Hydraulic oil should not be contaminated, so we have to keep it. For that we have to filter the oil, cover the caps, cover the tanks, etc. Keep the pipings, etc. tight. So that is the first point. Second one is plumb the system with pipe, tubing, and are free from rust, dirt, etc. So whatever the piping we are using, tubing we are using, they should be fitted properly and they must free from dust, dirt, etc. Third one, flush entire system with type of fluid to be used before normal working. So we have to flush the system or entire system with fluid to be used before normal working. It means with the help of normal oil. Now filter oil before using it. Change the fluid and filter after initial 50 hours of use, so that we can remove the factory borne contaminants. Sixth one is seal the system to avoid airborne contaminants. Sealing means cover the all opening points. Then maintain the fluid viscosity and pH value within recommended level. So viscosity should not change. If it is less, then oil will become thin. If it is more, it will become thick. So it should be within the limit. Then minimize source of water entry into the system. Water should not enter, so avoid that one. Select best quality seals. Then avoid introducing thread sealants into the fluid system. So sealants, etc. we are using for fitting the tubing, etc. So that thread sealant should not enter into the system. So with these steps we can avoid the breakdown of the hydraulic system. Now 14th question, write the maintenance schedule of hydraulic system. So maintenance schedule, weekly what we have to do, or periodically what tasks the operator has to do, that is the list given here. So A, first operator task to be undertaken during the operation of the plant. When the under that A, that is operator task, what he has to do: visual examination of system for damaged or leaking pipes, fittings and components. Then visual examination of fluid level, reservoir and the fluid condition. Visual check of operating pressure. Check whether guards are in place, covers, guards, etc. Then B, periodic maintenance. Weekly what we have to do: carry out operator task, what above 4 we have explained. Carry out or check fixing of all units, means nuts, etc. Check pressure readings at the test points, whether there is a correct pressure or not. Check pump for noise level and temperature. Check all actuators for damage, noise level, operating temperature, output, speeds and forces, etc. Check pre-charge of all accumulators. Check for correct operation of interlocks. Then C, annual maintenance. Annually what we have to do? Empty fluid reservoir and check fluid condition. Clean reservoir internally and externally. Examine for rust. Examine all hoses, pipes, fittings, etc. Where as leaks, replace as required. Examine electric motor. Examine flexible coupling between pump and motor. Check filter elements. Replace any which have been in service for 12 months. Clean filter bowl. Check filter condition indicator for correct operation. Check leakage of pump and motor. Check leakage across the piston, seals, etc. Okay, so next we'll go for 10 marks question.